Let's do this. Let's do this the way you're used to. Hello, everybody. I'm Nick, and in this video, that's the easiest joke. I keep making it for the past 2 years. You're all laughing, so you're to blame. Hello, everyone. How are you doing? Second day of NDC. Can I have a hell yeah? Hell yeah! Nice. You're awake. Yeah, I don't know how you're gonna be after lunch, but for now, you're good. Awesome. So, yeah, let's go straight into this topic, which is a very interesting topic for me, logging. And I want to talk about the title a bit, but before I do that, just in case you don't know me, hey, I'm Nick. Oh, wow, I can see your faces now. That's nice. I make YouTube videos, I'm a bunch of other things, and I have a podcast because I just turned 30, and that's mandatory. And I also run a platform called Dome Train where I sell my own courses. If you want to master any of those topics I talk about, you can check that out. Now, actually, wait a second. How many of you know me from YouTube? Show of hands. Those of you who did not raise your hands, take out your phone now and subscribe. Now. It's free, and it makes me feel nice. So, okay, enough with the sellout self-promotion. Let's go straight into the topic. And I want to talk about the title for a second, because if you watched any of my videos, if all of you have, you know one thing about me. I'm a bit of a, I don't want to say clickbaiter, but I'm pushing it, is what I'm trying to say. So me being here and saying, hey, you're doing it wrong, how do I know that you are doing this thing wrong? And I'll tell you a bit of a story. I was a couple of weeks ago, actually, I was in Romania, and there was this keynote in a different conference called .NET Days, where Rachel Apple worked for JetBrains, a great speaker. She had this talk about dog patterns and how people want you to click on things and try to convert, and she was talking about Audible not allow you to cancel your subscription and so on, or clickbaity titles in general in videos. And I thought that this slide would actually turn to something like this, which it's pushing it. But if you have to know one thing about clickbait, is that it actually works pretty well. So don't hate the player, hate the game. And obviously, this is a full room. So we're all here to talk about logging. And one thing I have to make very, very clear is that other than just a few things, there is not so much in this talk that is actually opinionated. Some of those things are actually factually wrong. It's not that I think it should be done a certain way and you're doing it another way. It is that that's how you should do it, and if you don't do it that way, you want to have an issue in your code. And when I do mention an opinion, I will say that this is an opinion. You don't have to listen to me. What do I know anyway? So let's talk about what this talk is not about. This talk is not about any of this. So as I'm going to show loggers, I want you to raise your hands if you've used, are using, or know the following technologies. Logly, anyone knows what that is? Yeah, okay, not so popular. Sec, okay, more hands here. How about CloudWatch? AWS, okay. How about Application Insights? Azure, huh, am I right? Microsoft, yay. You sellouts. How about this one, Datadog? You guys have money. You don't pay the bill on this. I would have a joke about GCP, but I don't think anybody uses GCP, so I'm just gonna skip that. So it's not about any of these services, which I'm taking the piss out of them, but they're all great. At least 3 of them are. It's about this, really. This talk is about the code you write, your own code. If you've ever written a line of code like this, like have you ever logged? Don't be afraid if you haven't. Yeah, come on. Yeah, I want to be awake, fine. Because I'm assuming if you don't raise your hand, you've never written a single line of code that logs anything. And that's scary. Because when things go wrong, you want to know how they went wrong and where they went wrong. But ultimately, this is about the real world. Now, as I'm going to be going forward this talk, especially in the first half of it, I want you to stay awake. I'm honestly not trying to sell you a performance talk as a logging talk. I promise this is a logging talk. But I also really like performance. But what we're going to see has nothing to do with performance directly, meaning the performance improvements we're going to see and the reasoning I'm going to give you in this talk is actually a knock-on effect of doing logging right. It is not we doing logging right because we need the performance. And ultimately, it's just about the real world. So I want to ask a question, another one. What is this? Obviously, this is a line of code that logs something. What is this more specifically? Can anyone shout what this is supposed to be? Who said? Template. Right. Let's see what Microsoft says that this is. This is the message. The message. But it's not. It's actually the template. You're right. So let's establish a few things. I want to have a theme going on. And you need to, that is the most important thing you need to understand, that this is actually the template and that it is not the message the same way that Microsoft tells you that it is the message. Because every problem, or the majority of the problems, actually stem off of that. The idea that many people think that this thing is the message, because Microsoft tells us it's the message, and not the template. So, well, first, Microsoft is terrible at naming. We're going to say it over and over again. Anyone working for Microsoft here? They're great. What a company. I love it. So let's establish the theme of this talk, which is Nick's 8 logging rules. Rule number 1, the message is actually the message template and shall be treated as such. And this talk will explain what that means. But has any of you, please raise your hands like this is important, used string interpolation when logging? Oh, OK. Whoever raised their hand, actually, let's continue. How about string concatenation? How about string formatting? You just validated the title. All of these are wrong. And we're going to see why they're wrong. And let's start with the first one, which is string interpolation. Now, string interpolation is a fantastic feature. I absolutely love it. Because when you have a message like this, user Nick Chapsas just turned 30, which is actually true. Thank you very much for the happy birthday. Then if you want to parameterize that, you might write something like this. And even though this will actually work, you have user plus Nick plus whatever, or name plus whatever, just turned 30. This is fine, but it's a bit clunky. Can we improve it? Well, we have a few approaches we can follow in .NET. The first one is string concatenation, so string.concat. And in case you didn't know, what the compiler will do with this one, actually, is lower it and turn it into this. What we can also do is string.format, where you can have an indexed parameter, and then you can pass them as secondary parameters, and then they will be replaced into the string and build the string that you want. But in C#6, I want to say, we got a really neat feature called string interpolation, which from what I understand, all of you know and love. And it's this idea, you just put a $sign in the beginning, you have curly braces, and then you can wrap your parameters, and then you don't have to have the pluses, which can lead into mistakes. In fact, looking at this code, I do have 2 mistakes in my string concatenation second line. I missed a space after user. So very neat feature. And if any of you are doing Java as your main language, then you're still stuck in the second version of this. I'm sorry. Eventually, they're going to figure it out. Now, one thing you have to know about C# as a language in general is that the way it was shipped for years now in Windows machines, mostly, really prevented it from being patched. So when the CLR, when .NET, the thing that actually eventually will run your code, needed a new feature implemented, Microsoft wouldn't really touch the CLR, we wouldn't touch the runtime because it's very, very dangerous. So what they would do instead is they would take the high-level C#, that nice new feature, in this case string interpolation, and then write some magic into a middle step before the final compilation called lowering, which actually takes that and converts it into low-level C# that you don't have to write, which is more of an elegant approach, and it's way less likely it's going to break a runtime that needs to be patched. However, with .NET Core, this is no longer the issue, because when there is a problem, we get those, I think it's not bi-weekly, fortnightly, once every 2 weeks, we get some patches, some changes. So if there's an issue, you can just take it, update your Docker images, and you're good. But because of that perception, Microsoft has really been shipping features with mostly syntactic sugar. In fact, the only two features that we finally got now in C# 11 that are not syntactic sugar is generics on attributes, which wasn't possible, now it is, and the fancy static abstract members on interfaces. Amazing features, but they did require a CLR update. And string interpolation, having been shipped in C# 6, was the same. String interpolation actually is being lowered from that to string.format. Anyone stuck or still is in C# 9 backwards. And I'm assuming everyone else is C# 10 onwards? OK, no, you're just lazy. OK, cool. If you're still in C# 9 and backwards, then that is still true for you. This actually has changed nowadays, and it's not as bad. And we're going to see that as well. But this is your reality. Your string interpolation is nothing than a fancy string.format. Now, why is that bad? Well, both string.format and string.concat have a bit of a similar issue. I don't know if you can spot it. This object array over here, these parameters, this is the bane of my existence. If you've ever worked with code that needs to be super, super fast, this is very problematic. But to explain why this is very problematic, I have to explain to you how C# deals with memory. So please don't fall asleep. So C# deals with memory in two different ways. You have two places where memory can be allocated. The first one is a stack. The second one is the heap. Nick, what are you doing? Yeah, I promise. It's a logging talk. It's a logging talk. So stack. Let's say we have this method over here. So we have int age, we have the GUID, which is a struct, and then we have the point2d, which in this case initializes an x and a y random points in 2D space. And assume that this is a struct, which is very important. What this means is that all the values in this method can actually be allocated on a memory area called the stack. And that stack is very local to this method. It's called the stack frame. So that's how this thing would be allocated. Now, a bit of an asterisk here. There are a bit of more nuances if you want to be very pedantic about exactly what's happening. But fundamentally, what you should know is that this is what you're dealing with. Your 30 parameter is put in a location in the stack, then your GUID, and then the parameters of your struct, because it's deconstructed, and then put into the stack. Now, the good thing about this is that everything that the method needs is local to the method, which means that when you go out of that method and out of that stack frame, that memory isn't needed anymore. Now, we all know that C# is a garbage collected language, so if you create an object, it's going to need to be garbage collected eventually when nothing points to it. However, because in the stack we can guarantee that once you're out of this area for something that can be put on the heap, then we can just deallocate it without having to garbage collect it. We just assume it doesn't exist anymore because nothing is using it. Now, the heap is a bit different. Same sort of example as before, but now assume that this person is a class, and this point2d is also a class. So those are reference types. They're not value types as we had before, which is the two main types of objects we can have in C#. What that means is that the memory doesn't exactly know how to fit those items in the stack. So for that, they sort of cheat and they go down the easy route of putting them in an area called the heap, which is just something else, somewhere else, where you can just have an address. Imagine it as a dictionary that says, if you want object 55, then that is there. Go get it. And what's going on behind the scenes is that eventually, when nothing needs or has a reference to object 55, then the garbage collector has the clear to say, I'm going to come in here and say, nobody needs that. I'm going to put it into the bin. Now, even me saying that something has to find something in an area and then do something to clean it up and deallocate it, sounds like work, and it is a lot of work. In fact, when that happens, because of how fragile the whole process can be, the whole application stops. Nothing moves other than the garbage collector, which means that you can really end up in scenarios where if you have a lot of memory to clean up, a lot of pressure that's being built, you're going to have these inconsistencies in performance because your application is pausing or micro-pausing to clean those things up. So back to how C# deals with memory, we have the stack, which is value types can be allocated here. So your integers, your structs, your goods, and so on go there. And then you have local variables and parameters in methods. They can also be allocated there because they're copied into the method and then maintained in the method. It is incredibly fast, like insanely fast. And it automatically disappears when it goes out of scope, like we established with the stack frame. Now, the other thing, the heap, is a bit more interesting because reference types are always allocated here, while in value types can be allocated in the stack, but they also can be allocated on the heap. And it's just this big pool of memory, and it needs to be garbage collected, which is the problematic part. So boxed values, and I want you to remember this word, boxed values will be allocated here. And if a boxed value is a value type, which it is a value type, then that's where it's going to end up. You're going to have to do something to eventually clean it. Now, anyone has seen this before? How amazing .NET is, like 1 billion requests faster than anything in the universe? Yeah, Microsoft made this. But it's independent. It's it's an open source benchmark, if you've seen this, that is very optimized. If you squint, it looks like C#, but it's not. But if you want to know how they achieve this and how .NET is actually very, very fast, is by removing a lot of the references you normally would have on the heap and putting them on the stack. So, and if you want to know more about that, I said I'm done with self-promotion, but I'm not. There's an episode on my podcast talking with Stephen Tobe, which is a performance wizard, and he explains all that more detail, and I pretend like I understand what he's saying. Now, like I mentioned before, we have the concept of boxing, which is the problematic aspect of value types being allocated on the heap. I promise this is a logging talk. So, back to original example, we have this int age equals 30, and I'm going to show some IL code. I don't know what it means. I can just vaguely tell you what it means. It basically just says put this value 30 into the stack. And that's that. There's no boxing happening. It's allocated there. And when we go out of the stack frame, it disappears. But then you have this, where we have the same age value 30, but this is now implicitly converted into an object. The compiler will allow it because the compiler is smart-ish. And the way this will be compiled into IL code is like this. So we still have this stack allocation, but then that is put into a box using the box instruction over here. And that process actually does take time. It is not cheap. During that process, that value type that could be allocated on the stack now goes into the heap, meaning it needs to be garbage collected as its own individual value. So depending on the processor you're running, those are some extra bytes you have to keep track of and delete. Now, the opposite can also happen. If you're trying to hardcast an object to its primitive value, the value type, then that needs to be unboxed. And that's another type of process that does take time and eventually return it. Why is that problematic? Well, we're going to end up with a lot of garbage, and garbage slows us down. That is a bit of a common thing. So we have the big two reasons. We have tons of boxing. We're going back to the logging. So if you have that object parameters array and you pass value types in there, they're going to be boxed. They're going to have to be garbage collected. You go on and on and on and on. And that's why we actually, I think in .NET 8, we're getting span on IEnumerable, so, or parameters on span. So we can actually prevent that from happening because you don't really have much of a choice currently the way this is built. And the other problem is a ton of strings. If you ever profile your application, especially if you're doing logging, and especially if you're the ones that use the raise your hand to say that they're using string interpolation on logs, then you're going to see a ton of strings. It's probably the most common thing you have allocated in your applications right now. And if it is not, you probably have another problem that you need to sort out. So more boxing means more heap allocations. More heap allocations means more work to set and retrieve values, which means more garbage collections triggered, which means more pausing to clean things up. Because we said you cannot actually do anything in your application if it is garbage collecting. And the other thing is tons of strings, which means more heap allocations because strings are reference types. They are put on the heap. And if you think that strings are only allocated once, even if they have the same value, you are wrong. Everyone heard of the concept string interning? Yeah. String interning is the idea that a string is only allocated once on the heap and then reused based on its reference. And that is only true for compile time string literals. You can also force a value to be interned, but that's not beneficial. So if you keep creating a string dynamically in runtime, you're creating a new unique string every single time, even if it has the exact same value. And that string reference type, it needs to be garbage collected. So super, super problematic. Now, that of course means more garbage collections to collect those strings because they have to be collected, and then more pausing to clean things up. But Nick, in C# 10, we got string interpolation handlers, and they fixed that. Anyone knows what string interpolation handlers are? Cool, I'll explain it. So we now have not, this thing can actually be compiled now, or lowered and then compiled to this. So we went from string.format with that problematic object array to this version. So if you ever try to use a website called sharplab.io to see how your code is compiled, that's what you're going to see for strings by default. And that can change based on different strings. But in this example, that's what we're going to get. And the good thing about this is that online, I should have numbered them, the one before the end, you see this generic int used. So generic actually prevents boxing. And if any one of you have been doing this for more than 20 years, I don't know, I haven't, then you would know that in the beginning we had constructs like an array list, I think, to store objects, and those did not have a generic type. And later we got list, and we fixed the list to a specific type. That heavily fixed performance, or improved performance, because you can no longer box those values, so you don't have to know what they are to take them out of the list. So this will prevent all the allocation issues that you have with the boxing side of things. But if you're using string interpolation, you are still allocating one unique string per thing that you're doing. And those strings need to be garbage collected. They will slow your application down. Now, in some scenarios, you cannot prevent it, but you should know it's there, and you should know that you can prevent it. In some cases, we're going to see them in this talk. So let's visualize this. If I have an application that just does a log.information log per a few thousand times a second over time, then my memory for this application, if I profile it, will look like this. So I have this spike of memory all the way until 16 megabytes over here, and this is relative to how much memory pressure you can tolerate in your application. And then it spikes, and then it goes down, and then it spikes, goes down, spikes, goes down. This tool is called .memory, in case you are not aware of it. It is a tool by JetBrains. They do not pay me, sadly. But what I want you to take a look at is, if you take a look at this thing over here at the bottom, those are milliseconds, or not milliseconds, but maybe microseconds, that your application is doing nothing but cleaning your memory. So this can still be very problematic. So rule number 2, I shall not use string interpolation or concatenation in the message template, because we established it is a message template, and that can be problematic. But what should I use? Well, structured logging. You should use what this template was made to be used for. If I go back to the following example, if I have a logger.log and I use string interpolation, and I start logging, and my application is running, and it's fine, and then I'm using application insights to push my logs, I'm going to see something like this. I'm going to get all my payments with my ID and failed with status, whatever. Now, in a real scenario, you would have a business person say, oh, we had an incident, and we have to get all the canceled payments, maybe within a time frame or within the last 24 hours, so we can get back and get the IDs and do something about it. Has happened to me. And you might say, I'm going to go here because I'm very smart. I remember that they end with the status code, and I'm very, very smart. So I'm going to go and say traces where message ends with canceled. Very easy. Sort by date, ship it. And I'm going to actually get what I need. And then the next day comes, and they come back and they say, hey, now tell me what happened to payment with ID X until it was canceled. Good luck sorting that out if you're using string interpolation, because you're losing all the information, all the crucial information that you could have in your logs. Now, let's do the following. Let's switch it up a bit. I'm going to use the template as it was supposed to be used. And please don't get confused here. There is no $ in the beginning of this. I'm just using a feature of my ID which can highlight parameters in structured logging and say that, hey, I have this parameter called payment ID and this parameter called payment status. And the first one I'm going to pass as an extra parameter is the payment ID and the second is the status. And if I do that, I have the exact same experience in application insights. But if I expand any of these individual log entries, watch what I have. Not only do I have the computed message, but I also have the original format in the third line, and then the payment ID and the payment status as individual parameters, or application insights called dimensions. There are different names for them, but it's the same concept. So as long as you use those templates, you can actually capture parameters and can go even further. You can actually time your methods and get that information as well. You can create scopes and so on. And now with that in mind, you can go and do something like this. You can say, give me the traces where custom dimensions.payment status equals cancelled. And assuming you're consistent with that parameter name, payment status, then you're going to get it. But it's very important. You have to be consistent. And you, especially if you're doing microservices, you don't just be consistent within your application, but if this payment status is the same sort of contract across your application, you want to be consistent across your service, across your system, the whole thing. That will make it very easy for you to identify what actually happened. Then you can go further. You can use things like the event ID or even the original format to search for something based on its message template. Or you can do other things, like I said, event ID. Any of you have alerts based on a specific look and feel of a message? So maybe you're using regex or something to identify a template. That's a very common practice. I'm not saying it's good, but this makes it very, very easy because you don't have to pattern match anything. You just say, if the template matches that, then here you go. Now, you might be saying, hey, Nick, this is still boxing. Yes, I'm not allocating a new string every time because now this is a compile time constant. I'm not computing it on every request. It is there. It is reused. It is being pointed at the memory, and then I'm just boxing the parameters. So the only string allocated for this operation is the one you see below, the payment with ID. Now, if any further allocation happens, that is up to the provider. If you're using application insights provider, if you're using Datadog provider, God forbid, great tool, very expensive. Or anything else. You only allocate a string, and that string is very, very problematic, and you're not going to have that issue. The boxing, in this case, until they eventually fix the parameters object array thing, you can't really do much, but it's going to hurt you way less than what these strings can do. So, rule number 3. I shall use structured logging and give good names to my parameters. But Nick, I'm using Serilog. Any of you use Serilog? I'm going to keep doing the hand thing. Awesome. So a fantastic library, Serilog. Serilog is just a logging library that did a lot of things right from the beginning. And it has this very nice concept of a sink, which is basically just a destination you might want to push your logs. And Serilog, you might say, does not actually suffer from all of those issues. And you would be half right. Let's explain why. There's, by the way, 2 ways of doing Serilog. The first one is using the raw Serilog iLogger. So you initialize your logger, and then you put it as a singleton into your DI container, and then you reuse that. How many of you use this approach? Cool. And then you have the other way, which is the serilog.extensions.logging package, which sort of hijacks the built-in iLogger, and it adds it as a provider. How many of you use this? Cool. The first ones are the right ones, but I will explain why. The second one is the better approach if you like to look at your code. The first one is the better approach if you like your code. So let's see how Serilog prevents log boxing, because they have the same issue, right? But Serilog is smart. They say, instead of having a single method for log information, write logs, log error, log critical, log, and so on, they thought, what if we make 10 overloads with 10 generic t-type parameters to prevent the logging? Wouldn't that fix the problem? And it actually would, because now you have an n amount of t-generic type parameters, and like we established, there is no boxing if you're using generics. Except it doesn't really prevent it. Dun, dun, dun. Let me explain why. And to understand why, we need to talk about the log level, which is a very funny thing to look at, a very funny enum to look, especially for Microsoft. I'm sorry. Because that's how they decided they want to write the log level. Starts with trace, goes to debug, information warning, error critical, and then they said, oh shit, we did not add none. We'll slap it at 6. And then what if you want to have one after this? Good luck. While Serilog has the same concept, but they said, well, why do you need none to be explicit? Just make it nullable and forget about it. So trace in logging in log level for Microsoft is basically verbose, debug is debug information, and so on, warning error, and then critical is fatal. Serilog is a bit grim, I don't know. Maybe it was made by Germans. But I prefer critical. Any Germans here? You're hiding. So what is the log level and why do we have this? Well, when you call log information or dot information in Serilog, behind the scenes what you're going to get is an overload that uses log level dot information, which is the log level, or log event level, which is how Serilog calls it, dot information. And then if you've ever looked into your app settings.json, because if you haven't, I'm scared, then you might have seen by default this sort of logging area. And it has a top level log level object, and then what's called log categories. And this Microsoft.ASP.NET Core by default is warning, meaning that if your logs for your ASP.NET Core operations are information or below, so trace, debug, or anything else, then and it's not higher than warning or equal to warning, then you're not going to see them eventually into your sinks, whether that is console, whether that is data, or whether that is anything. But anything else, the default one for everything else, starts with information. Now, out of curiosity, how many of you use information as the default for everything else? Don't be, it's not a trap question. Don't be afraid. It is a trap question. But I'll explain why later. If you take a look into log, the log method of the Microsoft Logger, they have this isEnable check over here. And if that log level is not enabled, so if you're trying to push a debug level log with log.debug, but your default is information, then it's not going to do anything with it because nobody cares about it. That, however, means that even though we do not push it into the provider or into the sink eventually, it is still boxing the parameters before it does this operation. Serilog is actually pretty smart. What they say is, I'm still going to have this isEnable check, but I am not going to box these parameters before I know that I need them. So they have the generics on the outside, then they have the check on the inside, and then they're boxing, which you cannot really prevent because somehow you need to pass those parameters. You can prevent it. We're going to see how. But what you can do on your own logging situation, and again, this depends on how heavy your workload is and how much you want to optimize it. But if you have something like this, you can totally take that log level, that is information, and do something like this and say, hey, if the logger is enabled for, or if it is not enabled for information, then return early. So you can make a method, compile time, can be very tiring to write all these methods to keep track of everything, but it can actually pay dividends in memory if you have a lot of log debug, or if your default is higher, and so on. So, rule number 4. I shall prevent unnecessary boxing for inactive log levels. This is a bit situational, and this is a bit of an opinion. But if you actually care about your application and your memory, and if you're in high throughput scenarios, then you can do that. Remember, memory is contextual. It does not mean the same thing for everyone, or performance is contextual. And I'm not here to tell you that everyone is processing 10,000 requests per second or more. But the good thing is that the .NET team has actually been pretty hard at work. Anyone know what a source generator is? Nice. So, Source generators were introduced, I think, in .NET 5, and what they allow you to do is basically mark some things into your code as this is maybe incomplete, or this could actually use a bit more code, but I'm too lazy to write that code every single time, which is a mindset I very much like. And why don't we write code that knows how to write code and implement the rest of the method? And since we have over here something like this whole thing looks like it can be automated, because if you have one per log information, then why don't we, or log anything, then why don't we just source generate it? Well, it turns out Microsoft has also problems, and they wrote a log message or logger message, a source generator. So what you can have is in a partial class, in this case, partial static class, you can have a public static partial void, you can give it a name, and you can say this. So this is an extension on the iLogger, and create your log item, your log operation. In this case, log payment failed. And then you can just say that the log level for this thing is information, and then the message is payment with ID and so on. This is a message template. They had the chance to fix it, but they chose to be consistently wrong than half right, which I like, actually, because that will be confusing. So, not too mad about this. And then you have the log payment error information, the log payment error extension method, which you can use in your application. So the same log entry as before now looks like this. And we still have the event name, the event ID, original format. We have the payment ID and the status. We don't lose any information as before, but we didn't have to write any of that code. Why is that awesome? It's awesome when you actually look into the implementation of what the source generator will actually do. Let's take a look at that. I know it's going to be a lot of code, so let me just point you here. The first thing you need to know here is that the log is enabled for your log level is added by default. Microsoft acknowledges that there is no point in wasting your time with unnecessary checks and moving forward. So the first thing they do in the source generator, and this is not configurable, is, hey, do I actually need to do something about this log? And if I don't, do nothing, go back, go away. But if I do need to do something, then I'm going to call this log callback. And what this log callback is a private static read-only action with actually three parameters, actually 4 parameters, iLogger, GUID, string, and exception, which is nullable if you have an exception. And if you remember the parameter methods we have a GUID for the payment ID, and we have a string for the payment status. That's what you're seeing here. And that field is actually effectively a cast method on how we are logging. It uses a logger message.define method, and then it source generates everything around that. What's behind that? Well, this. The first thing I want to show you is that you can actually configure if you want to double check the log level, but you don't need to have it in place. But what's very important is that you notice the absence of any object array or parameters here. That's because the compile time, we know exactly how many of those we need. And we have these new log values in line 4, which is a struct with generics built specifically for those parameters, preventing extra unnecessary memory. Now, I totally understand that this can be extra overhead in your developer flow, so maybe it is not for everybody. But if you can, you shall consider using source-generated loggers. They can really, really save a lot of memory and really improve your performance. And it's easy. You just write a single line of code. The rest of it is written for you. Now, I mentioned a feature before called string interpolation handlers. But did you know you can actually write your own custom string interpolation handlers? Because when Microsoft adds something new, they tend to actually open it up for everyone to use, which, depending on the documentation, can actually, you might shoot yourself on the foot. But if you're careful, you can actually get clever with tooling. You can do the following. We said that that's the default behavior of having a string interpolated string and then lowering it into the default interpolated handler. But default implies that you can have more. And that is true. I can actually go here and I can make a ref struct. I can call it logging interpolated string handler. And I can just slap the interpolated string handler attribute, and that makes it an interpolated string handler, which is a very hard word to say consistently. So excuse me. And then you can do whatever you want in there. In this case, I'm just cheating, and I'm reusing the default one and use that as sort of a store to eventually return my own stuff. What does that mean? Well, it means that I can actually implement my own methods to append it formatted and append all the other parameters. But there is no interface. That it uses like basically just duck typing, so you have to be very careful and match the name. But I can do something like this with a custom interpolated handler. I can say append formatted, use that generic t-type parameter, and then use the caller argument expression attribute that can point to another parameter, the message, to get the compile time value of that parameter. And if I do that, then I can call the internal handler, the append formatted, and make my own template, which means I can have something like this, which means I can have something like this eventually, so my front end looks the same. The only thing that changed is that I'm not accepting a string now in information, I'm accepting a ref of a logging interpolated string handler, which what you need to pass down is actually a string interpolated, an interpolated string, and this will work. And if you do that, then you're going to get this into your logs, which is this. Your parameter name will actually be used. You're still keeping those parameters as separate values, but then you don't have to keep track of everything and have templates for everything. This is possible, but it is bad. And if you consider doing this, I do not recommend this approach. And it is bad because anything you put into those curly braces at compile time will be captured and used as a parameter name. So if you do something like this, which you can, then your parameter will be called GUID.newGUID, literally, the string. Good luck filtering. So you want to control your parameter names. You don't want to let it to chance to know what this might look like. So I shall not try to get too clever with tooling. Guess who did that and paid for it? Now, when I go back to the log level, just a little bit, I asked you before, how many of you use information as your default log level? And it was a trap question, and that will get a bit opinionated, so if you want to close your ears, you can. But when you have a log level like this, like information, and then you have warning here, what's going to happen is if I increase that Microsoft.ASP.NET Core, which is a category, it's called the log category, to categorize a set of logs, then if I just run a single normal ASP.NET Core request, then that's what I'm getting for a single request. That's a lot of strings. So that's why by default, we're using warning on the Microsoft.ASP.NET Core category. Out of all this, the only thing that I've written here is actually this one. Retrieved quote for currencies, GBP to Australian dollars, in 32 milliseconds. Now, if I'm not going to put you on blast here, I'm not going to get you to raise your hand, but if any of you are using information for things like ASP.NET Core logs, I want you to ask why. Because when are you looking at your logs? You're looking at your logs when things don't go well. When things do go well, I've never said, I'm going to wake up at 9 a.m. and you know what I want to do? Look at my logs. Nothing happened, but I feel like doing it. It's not something you would say, but when things break, you want to go and see how they broke. And some of you raised your hand when I asked, hey, how many of you are using Datadog? Brave of you to raise your hand. But I went to pay recently for Datadog, and they have the following payment types. They accept Visa, MasterCard, American Express, and this one. That's a kidney. It can be very expensive. And if you are a big company and work with Datadog for quite a bit, which I used to work for one, then they will tell you that, hey, you're overlogging. This is not supposed to be what you're doing. You're not supposed to be doing that. Have you considered raising your default log level to warning for your logs? Which is a very weird thing to say, but it makes sense when the only thing, it doesn't make sense if the only thing you're using is logs. But if you're using metrics as well, or some of you might be using OpenTelemetry, where we're going into a more in-depth situation, then logs for you are just a single tool. And you can use more to know if your application is working. You do not need to have a big, long string to tell you that things are OK. How useful is this to you? it's probably not so useful. You can get diagnostics out of this, how long the request took, and all that, and slap it into just a data store, maybe Prometheus, maybe you use Grafana to visualize, and so on. You don't need your log level to be so low. In production, of course. So, in my opinion, you should consider using warning as the default log level. It does not mean that you should have no information logs. You can control the category, if you remember in that app settings.json file, and still have some information logs, but you have to use them sparingly. You don't want to use everything. It's going to make your life so much easier as well when you eventually start filtering for your logs and want to see how your application failed. Now, how many of you have heard this quote before? Premature optimization is the root of all evil. Cool. Nick. I believe that the root of all evil is misunderstanding what this quote actually means. Because it is actually used as an excuse to write bad code that could be very good by default, and also to just throw a bit of a responsibility of knowing how to write performant code away. Because nothing from what I've shown you today inherently is about performance, but I'm sure some of you will walk out of this room assuming that this guy just talked to us for 50 minutes explaining how we can write fast logs, which is not the case. It's how you can write reliable logs and deterministic logs. So do not assume that this is anything performance related. But hopefully with what I've shown you today, because we did not just look into logs, we looked into boxing, memory, string interpolation, a bunch of stuff, struct. You can use all that knowledge to know how to optimize when the time comes to optimize, which is very important. It's one thing to say this does not need to be optimized right now, which I very much agree with. And it's another thing to say, OK, time to optimize. OK, how do we optimize? And then you know how to optimize, and then you do it. So I want to end this with another opinion, which is, why do we log? Why are we doing this? Well, ultimately, it's all about telling a story. It's about telling a story of how something ideally failed. It doesn't have to be about how something failed, but it usually is. Or at least you're looking at it when the time comes to see why something failed. And now there's books, and there's good books. Now, arguably, if you read both of them, you might get the same information from both, but you spend way more time on the first one than the second. The problem is that we are not with our logs what we in Greece call laconic. Any of you know what this word means? Cool. I was in Romania again, and apparently they have the same word in the vocabulary. I expected no one to raise their hand. Everyone raised their hand. So, yeah. Laconic has to do with Spartans. Not these ones, not these ones, these ones, the real ones. I had to censor it. So, the Spartans were very, very well known for obviously their fighting ability and being fighters from a very young age. But they were also known for being laconic, which has to do with Laconia, which is where Sparta is based. And the word, after all these years, actually means using very few words to express yourself. And I like to use the same sort of mindset for logging. Because the way I like to think about logging is I want it to be accurate, descriptive, and short. I don't want it to be lacking information. I want the same information, but with less fluff. Tell me what happened now, so I can act on it. I want to have consistent name parameters across my whole system, not just the application, the system. It's going to make your life so much easier debugging issues. And I want to utilize my log levels properly so I don't have too much chatter in my logs. So the final rule for me is rule number 8. I should only log what's necessary to tell a good story. Thank you very much and keep coding.